write an equivalent form of the rational expression 2a plus 10 over 10a minus 4. In a, by dividing numerator and denominator. So I can, for example, divide numerator and denominator by 2, but it could be any number. So 2a plus 10 divided by 2 over 10a minus 4 divided by 2. This will equal to a plus 5 in the numerator and 5a plus 2 in the denominator. In B, by multiplying numerator and denominator, we can multiply numerator and denominator by any number. We can, for example, choose 2. So it's going to be 2 times 2a plus 10, 2 times 10a minus 4. If we evaluate this, we're going to get 4a plus 20 and 20a minus 8. In C, by factoring and dividing out factors. So in the numerator, we can factor out 2 as a greatest common factor, and the same thing in the denominator, so we would have to factor out the same factor. So we can factor out a 2, which leaves us with a plus 5. And in the denominator, we're left with 5a minus 2. The 2 2's will cancel, and you're left with a plus 5 over 5a minus 2. In D, which has a term in a squared, in the numerator and in the denominator, so the simplest way of getting a squared would be just to multiply the whole numerator and the whole denominator by a. So a times 2a plus 10 and a times 10a minus 4, which will give us 2a squared plus 10a over 10a squared minus 4a. And then finally in E, with a numerator of 6a cubed plus 30a squared. So if we take a look at what we have in the numerator, we have 2a plus 10. So to turn 2a into 6a cubed, we would have to multiply it by 3a squared. So we multiply it by 3a squared. And if we multiply the numerator by 3a squared, we have to do the same thing in the denominator. We expand this to get 6a cubed plus 30a squared in the numerator and 30a cubed minus 12a squared in the denominator.